So next up, we have Roussi, whose name I hope I'm not totally killing, talking about event generators from Splunk.
So Splunk is a search engine, a log search engine. Like every other search engine, it's useless without data. And as you can see that blank page over there, it's pretty boring. And there is no "I'm feeling lucky" button to save you. So engineers create what we call add-ons that connect to the target system and pull the logs. We also have what we call apps that encapsulate the necessary information to present useful information about those logs to the user in terms of dashboards, visualizations, charts, such as this heat wave, which shows the amount of CPU used per host. It comes up from our Hadoop app, which internally uses a Unix add-on to get the resource usage. Yeah, more useful than the blank page. We have thousands of freely available apps and add-ons that pull data from the software that's all around us, from cloud platforms to network firewalls. Someone even wrote an add-on for drone autopilot and the Nest thermostat. There is a website called Splunk Base that organizes that content, and people can download it. Unfortunately for us, there is a lot of software out there that we don't have the specification for, or the source code, or the execution history. And we also have limited access to real production environments, often on the order of a few days or weeks when somebody is on site. So how do we test? Luckily for us, we have several physics PhDs on our team, and they all scream with excitement. Hey, in particle physics, we had a similar problem, and we got this right. They use a big machine to collide particles at high energies and see if something interesting comes up. Well, during the course of their research, they had to deal with many practical problems. The big machine is very expensive. In fact, very few entities in the world can afford it. Well, maybe Bill Gates can afford it. But not certainly the poor graduate student. It takes years to plan and build. When it's finally finished, a lot of the time it's down for repair and maintenance. And the little time that it's up, it's available to somebody else's experiment. So physicists, they had to create event generators to unblock their work and to allow them to move faster. Turns out event generators have been pretty successful. It helps them validate theories, estimate mass, so that to see where to look for theorized particles. The code and the trace for the generators are a form of a specification that is passed between the domain experts, the theoretical and experimental physicists. And engineers also use them to predict event rates so that they can properly test their detectors and the rest of their infrastructure. This is part of the physics event gen ecosystem. It's pretty vibrant, as you can see. For every particle class, there is an event generator. And there are multiple event generators per class, as people try to do better than the guy before. Fortran and C++ are kings because things need to be fast. And due to the nature of the quantum mechanics, most of those and the number of interactions that happen from the initial collision until the final set of particles are produced. Monte Carlo methods, probabilistic methods, are suitable to those problems. There is a public repository that organizes traces from simulators called HEPSIM. It's run by the ANL, the Argonne National Laboratory. You can check it out. But warning, those traces are a little big. And due to the number of event generators that are out there, and if somebody in the audience has written one, you should excuse me if it's not on the list. Physicists, they had to reach an accord for a common interface and later a data exchange format so that they can reuse their code. It's called the Les Houches Accord, named after the town in France where that conference was held. Well, it turns out at Splunk we have similar issues. A lot of our very first and most successful add-ons were developed on systems that we don't have regular access to. To test, we need to build expensive environments that are also hard to replicate. And we try to do that as much as we can. For example, over time, we've set up those rogue test VPNs that did get us some real logs, but also the angry look of the security team. Honestly, the engineers, they loved it that they had extra choice, that they could connect with their latest version of macOS or Linux when our primary VPN did not support them. But then you can't argue with security. So another problem that we had is that a lot of the software that we connect to is not open source or free. So how do we test? How do we set it up? Trial licenses. Turns out it was a big pain to update trial licenses for every 30 to 60 days over many, many machines, over many, many add-ons. Some of our test engineers just wanted to quit. Well, I'm glad they didn't. So we needed event generators. We needed them badly. Our event gens at Splunk, they produce either key value pairs or full text logs. We make sure that we use them to test our apps to make sure that searches run correctly and the dashboards are properly populated. We also use them to test our core Splunk infrastructure. And we found numerous bugs, especially related to performance and scalability. This is a diagram of our setup. Events happen. They're detected, forwarded, processed, indexed. Then smart people perform searches, ad hoc searches, design algorithms for analysis. Reach conclusions, write papers, troubleshoot file bugs, all the interesting stuff. In the simulated case, events are produced based on previous knowledge and go through the same exact pipeline. And for the impatient, and we engineers are impatient, there is a way to bypass all that indexing cost and go through the straight to the search through mock search results. Over the years, different teams at Splunk have produced many different event gens, again for their own purposes and the next guy is smarter than the guy before and does it better. But this is the one that we have posted on Git. It's written in Python. Comments are welcome. Honestly, it's a little dirty code, but it serves us well. Feel free to rewrite or contribute. We require all the add-ons that we or third party ship to contain event generation knowledge so that they can produce sample data out of the box. We also require those add-ons to include transforms into a common interface so that we can layer add-ons and apps on top of each other, and of course, their event generators. Record replay is probably one of the the oldest methods of testing, and probably one of the most useful features of our event gen. It's essentially a fancy way of saying I want to retrace all the paths that somebody has observed in the past. As the system is being used, traces are recorded, then they are replayed at the same rate at which they were observed. We also have a mode called backfill, which replays at a different rate, which we found it useful for when engineers want to quickly fill indices with data, or when we are missing data for a particular index or part of the index, such as between midnight and 4 a.m. for whoever knows what reason. There is also basic token replacement functionality, which is just a regular expression substitutes one token for another. We found it the most useful for timestamps, so that we can test searches like show me events within the last half an hour, or replace with the current timestamp for testing real-time searches. Performance and scalability. I don't have much to say. I probably can't teach Google or Twitter people how to make things fast and scale well. But here are some of the issues that we've encountered. We replay with a single thread to make sure that events are ordered correctly. When engineers don't care about the correct ordering, we have something that we call sample mode, and that can be parallelized. With single process, multiple threads, we are bound by the speed of light in Python, the global interpreter lock. We get that around with distributed workers and a message bus, pretty standard stuff. And honestly, the scalability of our event generator hasn't been that much of an issue, as it exceeds Splunk's limits. And the final slide that I have is on realism. It's mostly work in progress. Our event gen supports modeling basic transactions when there are common fields between different sources, between different logs. It is also smart enough to recognize that fields can have different format, but still have the same value. For everything else, there are extensions. We use extensions for when events contain complex XML, complex data such as XML or JSON. When there are complex relationships between fields in the event, such as internal and external IP addresses, or when we want to invoke fancy things like the Python chain library, the PyMC. Privacy is another big issue when it comes to realism. Unlike the particle physics, where no electron is going to sue you for revealing its path. Well, if something goes terribly wrong, the government might want to know. But in our software world, sharing logs generates liability. It has to be approved by legal, and we all know how strict they are. So companies are reluctant to share logs. Most of you smart engineers, we already know that it's far easier to get proper access to source code than it is to execution logs, unless you take a job at a company whose data is of research interest to you, or convince an internal collaborator to clean them up, zip them, and send them. We've been exploring some privacy-preserving protocols, electronic voting, homomorphic encryption, but those will take time to get practical. So given those challenges, there is a lot more to be done. Our engineers are not domain experts in every software stack out there, and we don't expect them to be. We are still scratching the surface of quickly understanding a system that we don't have a good knowledge of its internals through the amount of logs that we have. And the other talks yesterday, they talk about completeness and hard to reproduce bugs. We also, from time to time, encounter them. And we get bugs where the logs are simply not sufficient to figure out what went wrong, even at their most verbose levels. The good news is that new hardware, new processors, they support tracing in hardware. When those features are on, the irreproducible bugs are reduced to practically zero. For those of you who have implemented tracers in software, you already know how painful it is to have a constant back and forth with the chip manufacturers. Hey, will that new instruction break your tracer? If you're lucky that it does, you have to figure out how it works. You have to emulate it, or just throw the towel and drop support. Tracing, at least at the lowest level, it belongs in hardware. It's where it should be. We don't quite yet support some of those lower-level hardware features in our event gen, but we were working on it, and soon we might open source those. And the last point I wanted to make, I think the industry and the academia should share more when it comes to machine logs. We're good at sharing source code for those who try to understand it. We're good at sharing research, but machine data still ends up in their own silos. Butler Lamson, one of the pioneers of computing and living here in Cambridge, used to say, "Why don't computers keep a history of their execution?" I want to add to that and make part of that history available. It works for the physicist. I think it will work for computing, and it will make quality better. Thank you.
Thank you. So the first question is, what is event generation?
What is event generation? So it's events essentially represent a state that is essentially an output of a system, and every event is an intermediate state of that system.
What are the most popular event gens available?
Well, in the physics world, probably PTA is one of the most popular one. And in our machine world, I don't think there are. We had to write our own.
Can I define event in, say, a web-based software system and use it with Splunk Event Gen for testing purposes?
Yes, we can do that.
What is the API for event generation? Does it work with protocol buffers?
No, it doesn't work with protocol buffers. It just there is no need for Splunk anywhere in the stack. It can just take a regular log file and then output to a file. But we have a lot of plumbing that essentially talk to the Splunk instances the same way. At some point, we might support protocol buffers, but it's not yet on something that our developers have gotten their hands to.
How does one create an event generator in Splunk? Is that only set up by Splunk internal team, or can any Splunk user set up event generators?
So any app developer can set up their own. Essentially, you need the configuration file to say how the event generator should behave. And then it also needs sample traces from which we need to either replay or to sample from.
How do you evaluate the events event gen generated from a testing perspective?
Yeah, that's a good question. Sometimes there is a big gap between what we generate and what actually the behavior of our software. So for our own software, we've actually given that problems to interns. And actually, Sarah from Berkeley, she actually created several Markov models that for our searches.log for a model about how Splunk users navigate through the searches. We also have created other models for simple models for replication, for network firewalls when we have pickups and deny and accept events.
If events are caught in logs, how often or quickly does Splunk index those events? Real time? And how are those events, how is the data kept?
Yeah, it can index it in real time. And the length of time that it's kept, it depends on a retention policy. Some users want longer retention policies. Sometimes it can just be kept into the hot buckets for a few hours.
Can used event generators for sampling data?
Yeah, well, our sampling mode is what we are using. Essentially, we sample from the subset of the logs that the user has provided, and we either output them to log file or send them to Splunk.
Oh, how do you determine if an event generator is creating a representative sample of what users might expect versus random noise?
Well, I think I answered that question earlier. We hired the interns to actually build some of those models, and those Markov models, and then we can actually use those models to generate sample data.
And one last question is, how long do searches take to return results?
Well, it depends on the it depends on the type of the search that we have. Some searches are more complex. Others, they're just lookups.
What's the sort of long and short? Like, what would be a long search and what would be a short search generally?
Well, if you have to, scan, do a sequential scan, if you don't have an index for it.
Well, thank you very much.
Thank you.